That's pretty cool.
Well, welcome to Weather Watch, everybody. I'm Pete Pokran. I'm the systems administrator for the AOS department, and I'm not John. John is in DC this week, and Michael will be handling, Professor Morgan will be handling most of Weather Watch today. But I wanted to just quickly show you I've been talking about GO17 the last couple of Weather Watches. And since then, we've been getting data, and I've spent some time doing up some loops. So to just kind of give you a brief tour of what's available that all of you can look at. I'm going to do this from the screen so that I can. Okay, so our satellite page, if you go to the AOS homepage, I'll just show you how to get there. You go to the weather link, click on satellite data, and there's GO16 imagery here, the GO17 page is here. And it's set up similar to the original GO16 page. There's a section with 1 minute mesoscale imagery at the top, 5 minute what's called CONUS imagery. It actually doesn't really cover that much of the continental United States, but it's the same basic size of image. Images updated every 5 minutes. And then there's the 5 minute full disk imagery at the bottom, and I'll just quickly give you an idea of what kind of regions I've got on there. Something else new that I've got on here that I also put on the GO16 page, especially with the GO17, the GOES West imagery, a lot of times the mesoscale sectors are out over the oceans or over a part of the globe where it's not immediately obvious just from the image where it is. So I've done up these for both the GO16 and the GO17. It's a full disk image of what the satellite sees and where the mesoscale images are. These are updated every 5 minutes, so you can't actually click on it to get to the mesoscale image. That would be cool, but it gives you an idea of where the mesoscale imagery is in the event that it's kind of hard from the image to know. So that's kind of cool. But for example, here's the mesoscale sector today for over the Oklahoma, Kansas area. They're expecting severe weather in that area, so that's why that's down there. So this imagery comes in every 1 minute. There's visible, infrared, looks like that. 3 different water vapor channels. The water vapor channels are having some issues right now. I don't know if it's part of their checkout, their testing, or if it's something that they're working on. We had similar issues with GO16 when it was in its test phase, so I suspect that it'll be better at some point. But you can see on the mid-level water vapor, there's these lines that go across, and those are in all of the different sectors of water vapor imagery. And then the shortwave infrared. This can be really useful if there's fires. For example, when we had the fires in California a couple of weeks ago, the warm end of the temperature scale is colored red and yellow. It first goes to real dark black and then red and yellow. So if you see something like that, in general, it might be a fire or something really hot at the surface. Although sometimes in the summer in the mountains light up that color also, even though they're not actually on fire. So that's the 1 minute imagery. The 5 minute imagery, I've got a CONUS sector, which is basically the entire area of that 5 minute imagery. It covers the west coast of the United States and out into the eastern Pacific Ocean. So that's pretty cool. It's got the 5 minute time resolution, which is way better than anything we had with GO15. I think we got half-hour imagery at best. Let's see, there's also a U.S. West Coast zoom of that, which is a little bit closer in, gives you a closer view just of the west coast and the ocean along it. Let's see, I also have specifically the Southwest U.S., California, Nevada, Utah, Arizona, and then the Northwest U.S., basically Washington, Oregon, Montana. They're pretty close in the resolution. The spatial resolution is really high, but the area that you're looking at is pretty small, so sometimes it can be a little hard to see stuff out there. And then I've also got, because the CONUS region covers it, I've got, this probably won't have a whole lot of data because they're dark yet, but the Hawaii subsector. So you can see, this is actually pretty cool, seeing some of the airflow around the islands of Hawaii. So that's out there as well. And then for the 15-minute full disk imagery, obviously there's the full disk stuff. This stuff is just spectacular. Watching the ITCZ and stuff that's going on. Pole to pole, the whole Pacific Ocean, basically from the west coast of South America all the way over to New Zealand is over here. So that's out there. I also have basically what's equivalent to the Northern America crop from GOES 16 over the Northern Pacific Ocean. Basically goes from about the equator up to the pole. And then this is a North Pacific loop, which is basically similar to what we had previously gotten in GOES 15 for the North Pacific, the loops that we used to look at. I'm not sure if that's a better crop, but it's there to look at. And then because someone asked where's the Alaska love when I had Hawaii out there and no Alaska, we've got just one that focuses in on the Alaska region a little bit closer as well. So any questions about the GOES 17, Greg?
I like the Northwest Pacific loop, and what I'm most interested in looking at, particularly in class, is the the one you just showed a couple.
This one?
Yeah. No, the Northwest Pacific.
North Pacific. Oh, I see.
Or North Pacific. Yeah.
Yeah.
The problem with that loop and trying to use it in class is I want to look at the visible because I want to look at the low level clouds.
That's on my list of things.
And what I want to see is a 24-hour loop so I can look, because in class it's like noon until the sun comes up there.
Yeah, so you need yesterday's loop.
I need yesterday's loop, or just make it a 24-hour so I can look at the first part.
Yeah, so the North Pacific one doesn't exist yet. I've got to do that. The Northern Hemisphere one does, but of course, like you said, it's dark right now.
Yeah.
Okay, I'll see about, it would be very easy for me to add a 24-hour loop to this. MP4 loops, so this stuff is all HTML5, it's all web browser based. You can't like save the loop and take it somewhere. As you can for some of the GOES 16 stuff that I've got up there. So here's the GOES 16 mesoscale locations as well. It's kind of cool. For the GOES 16 imagery for this stuff, I do have MP4 loops that you can download, and that's on my list of things to do as well. And I can make a 24-hour loop of that as well. So it'd be big, but it's doable.
I don't think you have to do every color band. Just do the visible enhanced color, just one of them.
Yeah. I've got some other stuff on my plate too. There's some other pseudo RGB colors. They've got like combining different channels in an RGB format to be able to identify things like clouds and snow and other features that are pretty cool. So that's sort of on my list of things to do at some point as well. So that's basically all I had to say, was just kind of give you a tour of what's out there. It's on the AOS webpage, and have at it.
Thanks, Pete. So we'll get started. First, we'll look at the North American visible loop, and what we can see is a nice, well-known cyclone out over the Atlantic Ocean. Closer to home, we're sort of socked in with low clouds that have been sort of persistent for the last few days. And also, when we look at the surface map, we'll see that also there's a lot of fog being reported in the upper Midwest, kind of right over the snow cover that we have at present. Pete noted that there is the mesoscale focus that's out over the southern plain states. We'll take a look at that. That's going to be the expected area of some severe weather.
I want to point something out.
Yes,
right? If you look in Colorado, you can see the dry line. This is a classic example of this Martin Locatelli and Hobbs dry line coming off the mountains. You can see the precipitation forming over eastern or western Oklahoma and Kansas, and there's a low sitting now right in southern central Colorado.
Right.
And there's an upslope developing in the northern part of the state. So this is going to drop south right now. So this is a Colorado low that's developing at this time coming off. But it's interesting to see it switch from upslope to downslope just to the south. And you can see that.
There you go, the 1 minute stuff.
We'll go up a little further. So, right up there. You can see the upslope forming on the northern side.
Right. In fact, you can see the clouds forming, low clouds that sort of generally an easterly flow right up the slope of the mountains, and then you're getting downslope. I guess you're in this clear area.
And the clear area is the classic dry line. Now that dry line is going to move off, and those clouds are going to stick to dry line all the way across, and the cold front's over the mountains yet.
Right.
So it's an elevated cold front, it's not reaching the ground. So this is a perfect example of this John Martin thing, of the dry line moving off the Rockies.
And we're going to see that this, Greg was suggesting, there's a surface cyclone located over southern Colorado. Look at a surface map at the moment, but that'll also be playing a significant player, one in the outbreak of severe weather that's going to be entered with southern plains, as well as in the producing some snowfall for the northern plains, as well as the upper parts of the upper Midwest to go into the weekend. So those are going to be the big player that we'll be focusing on today's discussion. So first thing to do is
Looks like there's a John Martin East Coast cyclone up in the Atlantic as well.
and I'll take advantage of this not being here. Simon does. I already know that
It does occupy a pretty significant part of the North Atlantic, though.
Right.
That's saying.
But yeah, so it is an interesting storm, but I guess the one that's going to develop here would be probably one that you would also be kind of excited about.
Yes.
So let's first go to the radar, please. This composite radar loop, as Greg was saying, here's the precipitation that's already beginning to develop across parts of Oklahoma, the Texas Panhandle, and parts of Kansas. Not much precip, or it's relatively light in the vicinity of the foothills of the Rockies, foothills of the Rockies, Rocky Mountains at this point. You can sort of see the outline of where the Rocky Mountains are from the reflectivity there. So it doesn't seem like it's very well organized or very energetic storm at this point, but it's still early times for this particular event to get going. So we'll see when we look at the upper air maps, the structure of the surface trough, where the surface cyclone is located, and we'll see the progression of these features as they begin to come together over the central part of the United States. Elsewhere in the southeastern part of the United States, sort of showery precipitation, hopefully scattered precipitation. And in fact, you wouldn't guess this, you might think, oh, these might be some thunderstorms, but I think it's unlikely they are. The only places that are reporting lightning are actually out over the Gulf of Mexico and the southerly flow that's moving into Louisiana. Let's go to the lightning detection network. These are surface-based sensors, but I guess in the GOES data set that we're getting now, we can actually get the GOES lightning map, right?
I'm not plotting any of that stuff up.
Not yet, or just won't be doing that?
Not yet.
Okay.
Haven't really had a chance to look into it.
Right. So here's the areas.
Surface-based.
Yeah, the surface-based from the lightning detection network. This is the only places that are reporting. Again, these are surface strikes, not in-cloud strikes, but cloud-to-ground type strikes that are well south of the Gulf Coast.
So the way that the GOES instrument detects lightning is a little bit different than what you're seeing here. What this is, it's basically, if you're listening to an AM radio and a lightning strike happens and you hear that, there's an array of antennas around the United States that detect that signal and triangulate between the different antennas to figure out where the strike happened and how strong it was. And so that's what these individual points are marking. The GLM instrument on the GOES 16 and 17 satellite actually detects light from the top of the cloud. So when a lightning strike happens, you can see the change in brightness. And I don't know exactly the details of how that works, but it detects like flash density and flash area. And I think it's over a fairly coarse 20-kilometer perhaps area. Maybe it's not quite that coarse. I haven't really played around with that much yet.
That'd be a nice new tool to look at, particularly if you're concerned about lightning strikes over time. Okay, let's go next to the surface map. We'll start in the upper Midwest, look around here, and then we'll broaden the picture. We are in Madison at 32/27 with a east and northeasterly wind, 6 miles visibility. You can see these sort of infinity symbols here. Doesn't mean infinite visibility, 6 miles, 6 century miles. It's just a haze being reported across a good portion of the upper Midwest. 33/27 in Rockford, so fairly uniform temperatures over the northern parts of Illinois and southern Wisconsin. And if you scroll down a little bit now to Texas, you can see you now have sort of juicier air with dew points already in the mid-60s, approaching 70-degree dew points. Southern Texas, we're up to 70 with the dew points. That's Midland right here at 74, we're 56. So dew points drop off a little bit, but the big drop of the dew points really occurs once you get out over, I guess this is pretty close to where the dry line that you're doing, Greg, is. These dew points dropping rapidly down to 27, 28. So very dry air. Again, that dew point is the temperature you'd get where condensation occurs. You were to cool the air isobarically until condensation occurred. So really dry air right over the parts of New Mexico. We move a little bit further to the north. We can look at the surface pressures on this map: 1,004.1, 995.5. So there is a minimum in sea level pressure located right about here. You don't see it. You get some evidence of a closed circulation. But remember, when you look at these maps, some of these stations are in the mountains, some of them are at much lower elevation, so it's really hard to depict a nice, clean, closed circulation. But in the northern part of the state of Colorado, we see that northeasterly flow, and that's helping to produce the upslope. But the northern and northwesterly flow right here is kind of trapping the cold air right against the Rocky Mountains. And in the southern part of the state, we have more of a westerly flow, a downslope and off the mountain type of flow. So surface circulation is roughly in this location at about 995.
It appears that most of the precipitation bands that you see on the radar over Kansas and Oklahoma, most all of that is not reaching the ground.
Yeah, and in fact, I mean, it's close to saturation, 41 over 41, 34, 34, but it could also be because it's between stations. Can we zoom in, get a Central Plains surface map to see if any place is actually getting precip? Here we go. So heavy rain at this station here in
Why wasn't that showing up before?
I think it's because it's in between stations. This may not have been plotted. So it's a very thin region, narrow band where the precip, which is just not present. Here in northern Texas, we're getting light rain and pretty decent dew point depressions in these regions as well. You can really see some evidence of that cyclonic circulation developing, but still not a well-developed surface like at this point. Let's go back a quick and surface maps. Let's now move to the superheats. We'll start off at 850 hectopascal and we'll work our way up. All right, so this is at 12Z this morning. Again, kind of an awful looking map analysis. If you did this by hand, you probably get those points, but this is, you can see over the mountains, it's really tough to get. We don't have any wind observations here. But you can see a broad trough that's located just over the Rocky Mountains this morning. This broad southerly flow from the Gulf of Mexico into the southern plains. Not particularly strong right now, and we'll see that the shear, at least this morning, wasn't really significantly directional, but there is certainly some speed shear that's occurring. We'll see some evidence of warm advection and winds veering with height out over the southeastern part of the United States in just a moment. So southerly flow here, broad trough over the western part of the United States. Let's go to 500 millibars. Actually, can you go back to 850 for just 1 second, please? I'll point out one other aspect of this. In terms of the baroclinicity in the lower troposphere, it's a nice north-south thermal gradient that's located here where the isobars or isotherms at this level oriented from west to east. Modest baroclinicity, and that is the horizontal temperature contrast that we see on the map. Just in the lee of the Rocky Mountains here with this thermal ridge. But you wouldn't get perhaps necessarily.
You know what you really still don't see at 850, and I guess you can't, is the upper level front.
Right, that doesn't show up there. At 500 millibars, it's also, we'll go to 500 millibars now. It's not perhaps the most impressive that you'd see. Here it is, maybe in Southern California, northern Mexico, northwestern Mexico, you can see a pretty significant thermal contrast with this upper front. But the baroclinicity at this level isn't the most impressive.
About 700 millibars, can you see it there?
We can check that out. We can also do a cross section in a moment. Do that. 700 actually shows up pretty decently.
Yeah.
At this interval of 5 degrees.
So that's part of that Martin Locatelli and Hobbs thing. The upper level front is coming across. And the lower level, the dry line, is defining the precipitation band instead of the front. And eventually they may merge together further in the eastern part of the
Right, as it develops. We'll see that, I think, in the forecast evolution. So at 700 millibars, the trough is still located out to the east, out to the western part of the United States. You'll notice there is actually, I correct myself, we had southerly winds earlier, now the winds have veered a little bit to more southwesterly. So this is indicative to the extent that the winds are nearly geostrophic. This veering of winds with height, turning of the winds with height, indicative of warm advection over the southern plains. Let's go up to 500 again. Nice curvature, so nice vorticity maximum located back over southwestern in Arizona. But again, the barraconicity is just tight in this region, just in northern Mexico, northwestern Mexico, and southern California. Most of the rest of the country is fairly quiet. We do have a broad region of confluence over the northern part of the United States, with modest barraconicity, so this is a weakly fronted genetic flow, and so that could foster some ascent, so sort of a Soria-Liasa-driven circulation across the, northern Missouri, Iowa, and Indiana later.
This is kind of almost a springtime pattern. We're getting this rapid fire now, short waves,
Yeah.
and a fairly zonal pattern overall. We haven't seen that because we've had that blocking ridge on the west coast for the last few weeks.
Right.
And now that's broken down, and now we got this one after the other
Right.
short waves moving through.
Yeah, so this came onshore just yesterday morning. It was located just west of the west coast of the United States. It's moved in pretty quickly, and it's going to be, into the Central Plains by tomorrow. This next short wave that's further upstream, we'll see it in the forecast. It's also going to be fairly things are moving much more rapidly than we've seen over the course of the season thus far. Let's go to 300 millimeters. You can sort of see this nice, well-developed jet maxima that's on the upstream of the trough axis at 300 hectopascal. You can also see this other modest jet that's associated with that region of confluence with some 500 millibars and the intensification of the thermal gradient. That's to give you through thermal imbalance, those local maximum winds across the upper Midwest. And the other trough that we saw, probably near the peak of it, where this is a fairly deep trough that's over the western or eastern part of the Pacific. You can see it in the height field, and you can also see it's locally warm here. So like that, we don't have 400 millibars, do we? So this is minus 40, minus 50. So it's warm here where we have the cyclonic vorticity. We're probably just above the tropopause at 300 millibars. So fairly deep tropopause is probably located right over the over the northeastern Pacific. In fact, if we go to your satellite imagery, just take a look at that trough. You said you had an image that was a week long? Yeah. So Pete put together a week-long satellite image.
Water vapor.
Let's look at water vapor. I haven't seen this one, but it might be more interesting. This is a week-long.
So it's got these bands in there, and there will be a glitch in here where it basically goes to all horizontal lines. That's the sort of thing you see with when the sun's shining in, the heat on the detector I was talking about a couple weeks ago.
So 25th is
right there.
Yeah,
that's the sort of thing that happens.
6th, so this is Monday. You can see again, very active Pacific with lots of these cyclonic circulations. We're now in Tuesday, about to go into Wednesday, and then we'll begin to track some of these features as they move approach the west coast. But here's a really nice cyclone turning. This warmer color region right here is indicative of air that's had a history of subsidence. So it's perhaps the backside of an upper front. There is, in fact, the west coast yesterday, and then you can see it as we go into this morning. We'll leave it there. We're not going to redo this, but you can see this region, this strip of sort of warmer temperatures on this scale right here are indicative of air that has very low water vapor content. That's air that subsided from the stratosphere into the upper troposphere and is rounding the base of this trough. And this is coincident with what we saw in the maps we were just looking at with the enhanced barraconicity here, enhanced curvature we can see in the wind field, as well as the that enhanced barraconicity is indicative of upper front. We can actually do a cross section of that in a moment. The other area that was over the Pacific that we were suggesting was associated with a much lower tropopause. It's going to be also associated with very cold air aloft. And I think this convection that we see, the speckled pattern that we see here, is indicative of really cold air in the upper troposphere, mid-troposphere actually, beneath the very deep upper trough, substantive upper trough located here. So that's why we see this convection there. It's unstable out over the North Pacific.
Is that surface convection?
We can look at the surface map at this point, right? Surface imagery. Probably surface or mid-level, mid-troposphere convection. I would imagine.
That's what I was thinking.
Yeah. Just so cold. Can't
You like the
see
loop of it, or didn't see a shadow from this upper stuff up here?
Right, so that's another deep trough that's out in the Pacific. I guess it's in this region right here that we were looking at earlier. I'm not sure if it's this disturbance.
Yeah, we're gonna have a hard time seeing that on the 5 minute stuff. It's just right on the edge.
Right.
Hmm.
A little bit.
Actually, not the parent, but the guest in this region. You also note that it's not that feature that we were looking at. We can scroll over just a little bit that was off the west coast of the United States and the southwest United States. Look at this, you see, not much is happening, but there is a fairly potent upper trough that's not seen here because it's pretty dry in the mid and upper troposphere, almost devoid of any cloudiness. And the real action is happening to the east of the trough where we see this ascent just beginning to occur.
You can see that surge of cold air behind that low up there in the northwest.
Back to
No,
here,
no,
yeah.
up in the, right about there. Yeah, look, you
Right
can see
here,
the surge of the cold, you can see it in the cloud patterns. See it surging, there's like an Arctic front plume of cold air moving south right in the west side of that low.
Yeah.
See it? You can see it in front of Genesis on the edge of it as it's moving down.
It's kind of organized.
No, back up in the,
Are you
way in the
going
northwest. Look right up there. See that? See it bunching up the clouds at the bottom, at the southern side? Yeah, right there. Watch that come through. It's a surge of cold air.
Pretty cold air, and that's, again, beneath this upper vortex that we see on we saw 500 millibars. And we saw 300 millibars go back to 300 millibars.
What's this linear feature here? This thing goes from like Baja all the way across up
Yeah.
into this, to the line of clouds with clearing on either side.
I think that's the edge of the tropical trumpet.
These are low clouds though, right?
Hard to tell based on
This
this.
could be on the periphery of that up just a broad
Yeah.
surface anticyclone or mid-tropospheric anticyclone. In case. Very nice. So 300 hectopascal, we see this, again, strong maxima, jet maxima here, and this is typically, just looking at the pattern of this sort, we might anticipate that this trough still has some more deepening to go as the jet maximum rounds the base of the trough, and this gets sort of ejected into the central part of the United States. So let's now look at the forecast. I want to just quickly check two things before we do this. I think it's already up. Go to SPC first of all, and just want to highlight that if you look at their convective risk for the next day or so, there is an enhanced risk for some severe thunderstorms right over the central part of the central plain, parts of Arkansas, Oklahoma, northwestern Louisiana, and northeastern Canada, Texas. And we'll see that's going to be a region. When we look at the forecast, we're going to see significant directional shear developing later this afternoon as the trough we saw at 500 millibars begins to head eastward, or continues heading eastward.
It's right along that dry line too.
Well, the dry line's more back here right now, right?
Well, I'm thinking it's going to be over there later.
Yeah, it'll be advancing toward the east. And I think if we click on that, we can sort of see the risk of, or go up here and look at the risk for tornadoes, wind, and hail. This is a pretty significant risk for the next 24 hours in this region. So unfortunately, folks down here, it'll probably be later this afternoon or tonight before that really gets going.
Tornadoes are pretty high. Well, so it's the first significant wave we've seen in a long time to come through in that zonal flow.
Right, at a very low latitude too.
Yeah.
As you said, this is more like late winter, early spring,
Yeah.
as opposed to overseas.
That's not unusual though, is it? I mean, they
No.
typically have a sort of twice a year.
It's getting a
severe
little
weather
late.
risk. It's early spring and in the fall when they
Right.
typically have it in southern.
This is December now, right? I mean,
Yeah.
Almost, yeah.
well, it's November
That's
30th, right? Yeah.
And just the other note.
But that's
that-
day two, so that's December.
Yeah, you're right, okay.
So the other thing to note about that wave was that it was one of the, I think the second in the string of the three that are going to be going through there that sort of quenched the fires, ended the fire issue that we had just in the last couple of weeks out over California. Now the issue is with significant precipitation,
Landslides.
lots of rain, landslides, mudslides.
Got a flash flood warning out this morning or last night, right? California.
Didn't check that. We can take a quick look. We go to Pivotal and click on Home. It gives us an issue of where watch looks like there are no watches.
Current,
Watches
the
out
last
there.
night. I mean,
Yeah. But we can't go back on that, but just a couple of the hazards that are coming up for the next 24-hour period. the legends down here, but we have winter storm warnings for a good portion of Nebraska and South Dakota, winter storm watches for southern Minnesota and northern Iowa. And a lot of places that are pretty dense fog. And these are just winter weather advisories for parts of western Colorado. And the high wind warnings they have here are associated with the fact that you're going to get this upper trough coming across the mountains and get really gusty winds as the cyclone begins to intensify. Looking ahead, and we'll get to the local forecast in a second, just in terms of thermal temperature anomalies, this is the next week ahead for us, and you can see a strong likelihood of below normal temperatures. The darker the blue is doesn't mean the colder it's going to be. It simply means that the likelihood, the percentage chance it's going to be below normal is significant, 90% chance, or 90% chance in this region. So much of the country is going to be below normal.
It's kind of misleading.
In terms of having that
It's not going to be that cold.
it's going to be below normal though.
Below normal, but I
Right.
mean, but it's not.
Well, if you're looking at temperatures around
You look
20
at
to
this, you think
25.
we're going to have an Arctic outbreak.
Yeah.
Well, the highs 20 to 25 are probably, if you have highs like that, that's pretty cold. I think normal, we can check the climatology for us, but I think normal's in the mid to upper 30s at this time of year. Take a look. Let's go to the state climatologist's office.
Yeah, okay.
But the other part of it is, Greg, you've lived here for a long period of time, and frankly, with average temperatures having gone up,
Yeah.
our climate is,
Yeah.
appears, things have definitely changed. So for the climate record, that when they do these averages or so-called normals, they use a 30-year average, ending in this case in 2010. And so for this time of the year, as we move into early December, 38, probably 38, mid-30s perhaps.
So people,
So if we're going to have temperatures, I think we'll see the forecast of temperatures for next week is going to be 22, 23 for highs.
Right.
That's
that's
10, 15
pretty
degrees below
cold.
normal. That's colder than actually if you go here. It's going to be almost as cold as what's typically our average coldest temperature that we've seen mid-January. So we'll be below even the coldest temperature annually, perhaps by early next week. And just keeping track of everything else. In terms of snowfall, we're kind of right on the money with that in terms of our year-to-date, but it's early times, and if we scroll up here for precip, obviously the rain above normal. Okay, let's get back to the forecast. See what's going to happen. We could just, for this one, we'll have another go up here, but click on this for just a moment, Pete, and go to Aurora to see if that's up. Please. Oh, please.
Oh, this train's
Current run. Just click on any of these. It's updated, so we're not going to. All right. Let's turn to typical weather. And the first thing I want to do is, this is the 6-hour analysis where we saw evidence of some convection, a thunderstorm in the Gulf of Mexico. Here's some of that accumulated precipitation over the 3-hour period ending at this point. And light showery precipitation we saw on the radar showed up. Precip in Texas, in northern Texas, Oklahoma, and Kansas, at least at this point, this is 6 hours into the forecast, hasn't really, doesn't really show up really well here, but we saw on the surface map evidence of a cyclonic circulation in southeastern Colorado. I think that was captured well in this short-term 6-hour forecast by the GS.
Well, it was in the northern part of Colorado. Now it's dropping to the.
Yeah, if we go back and click, you can use the mouse keys actually. I think. I don't think you maybe not.
precipitation rate at 3 hours.
Well, Bill, you can't go there now.
Remember, we saw the upslope before up around Cheyenne,
Right.
and
And that's consistent with this.
That's typical that it drops like that.
So if we click forward every 6 hours, let's watch the evolution of the cyclone.
Oh, it's a greater than.
What's that? Okay.
And then I'm just.
All right, so now we're at, 9 hours. We can just step forward here. You can see over the short term through tonight, basically staying dry, but you can see the cyclone beginning to consolidate somewhat over the Oklahoma and Texas panhandles. Pressure 996, 994, 992. So down about 3 millibars or so from now. And if we just continue stepping forward, another really classic structure that's evolving here, and we'll look at the upper troposphere in just a few moments, is this really nice thermal ridge. You can see in the thickness field, remember thickness is a measure of the average temperature in a layer. This is from 1,500 millibars. A nice thermal ridge that's beginning to develop here. And this is what Professor Martin refers to as a trowel type of structure. As the upper trough comes around and the potential vorticity maximum associated with it in the upper troposphere, it's helping to effectively twist these isotherms, the layer mean isotherms, thickness contours, into this thermal ridge. You're developing this thermal ridge that's helping amplify, that's associated with the amplification of the cyclone. Strong warm advection here, cold advection just south of the cyclone in terms of cold thickness advection. Nice sort of classic.
I think that trough extending westward across the panhandle, Texas panhandle, is interesting. Is that what kind of an Arctic front trying to develop as opposed to the upper? It doesn't look like it's a reflection of the upper level front at this point.
No, but I think the upper level front would have been further south.
Yeah.
Yeah, so this little trough-like feature here can be manifest by a surge in extremely cold air. Let's look at the temperatures, 2-meter temperatures, at least forecast by the model on this. And there is, I don't know how far back it was through here. We don't see much evidence of a strong thermal contrast north-south right here. But if we go to this and go to 925, just get a little bit of, or 850 actually for temperature. It doesn't seem like it. I mean, even here is added to the trough, there's not much of a signature of cold air here, so it's not really fun. But you can even see here, and this is 850 millibar temperature, the sort of ton of warm air that extends from southern Texas all the way sort of wrapping into the cyclone from the southeast, south and southeast. Sort of a classic depiction of a developing cyclone. Not much enhancement of the thermal contrast with a shift in winds indicating an obvious surface front at this point either. And while we're at it, this is 0, this is 60 tonight. We have winds basically out of the south and southeast. And if we were to go up to, let's say 500 millibars, what's the wind direction there? So the directional shear isn't particularly significant by 60 tonight. Maybe that might suggest that the threat for
There's the upper level front.
should be over. Yeah. Here you can see a really strong thermal contrast. You have the thermal system here, and also this warm thermal ridge extends even all the way up to 500 millibars.
So I think that trough was the upper level front. Excellent. Because that looks consistent with that upper level trough that was along the panhandle.
Right, but it would then seem like the cold advection is out ahead of that trough. Because this is where the cold air is right now.
The cold advection was from the north to the south over the panhandle, over the northern panhandle right there. So that's where it was at that other time. Is this later or earlier than the previous one we looked at? This is later, right? I mean, if you look at the surface,
It's the same time.
it's the same time?
Yeah.
Well, that is strange, isn't it? That you have that trough there, but nothing at the surface but the 500 millibar has a very sharp contrast. Yeah, I don't know. The front can't be sloped the wrong way. So I don't know.
So we'll go to another site and just quickly do some cross sections through it. If we continue advancing ahead, again, the strong gradient in pressure that's manifest by these black contours indicates fairly strong surface wind. We'll look at that in a moment, but we're still no precip for us, but heavy rain, again, from the Gulf states all the way into southern Iowa. And on the northwestern part of this, again, it's not super cold air, but we're getting, these are the regions that are experiencing snow. This is now by tomorrow mid-morning. The cyclone is deep in 990, 988, 986, so a 985 or so. Cyclone center in north central Kansas. It's close to its peak intensity at this point, but really not an obvious cold front, I think, associated with it. Thermal ridge, at least in terms of thickness ridge, extends back from here, but it's not going to be as obvious as when we look at 850 millibars. It's sort of a westerly flow. Some of this is downslope as well, and clearing out for the southern plains with a threat, I guess, of any severe weather along the east of this. But this cyclone is now at 987 or so. And we step forward. Let's go 6 hours, 36 hours. Beginning to fill a little bit. But for us, at this point, we're just liquid precipitation. This is by tomorrow evening. If we click right here close to Madison, We look at a profile of temperature, and you'll see that for about 700 millibars and down, we're going to be above freezing. Actually, 700, we're well below freezing, but it's about 750, 800 millibars is where we go to zero, and then we have a layer, that's what, 1.5 kilometers, over 1.5 kilometers deep, that's going to be above freezing. So very likely liquid precipitation for us at this point. Not much wind shear. The very, very close to the surface, we see the wind varying a little bit with like warm convection, but that's about it.
We've seen this, this is like the third storm in a row.
Yeah.
That's come from Colorado and is elongated when it got to our south. What's going on? I don't remember seeing that very often previous.
Multiple times in a row, but I wonder if we looked at an average set of maps, maybe there's some broad scale deformation in the larger scale flow that's helping to stretch these storms out as they head toward us. But it's a good question. I haven't looked at that. We look at 500 millibars, maybe we can get some clues or another levels.
We're in some kind of a strange situation, but this pattern is totally different than we had a week ago, and yet it's again elongated. I mean, it looks like it's going to.
There's a large ridge that's located. There's there, it's a drop, but in the passage of these, we've had this sort of high over low type pattern that's gone by.
I mean, why doesn't that storm, when you look at it, you think the storm should just come up through La Crosse, and yet it elongates and goes east.
Let's go back to the surface and we'll work our way back up there. So 36 hours for here. We'll go to 48 just down, advance a little bit. So this is Sunday morning. And as Greg was saying, the storm kind of elongates, and in fact, at the center left here, the primary center, you have this elongated trough that's near the axis of the thermal ridge as this begins to propagate by. I think part of it's that the upper trough is still stuck back here, and the surface component of it that interacted favorably for the development over the plains has just run out ahead of it. So, but the other message here is we're still very high thicknesses, liquid precipitation occurring, and the snowfall is going to be just northwest of the cyclone side. But also, I would say this is not super cold air. We have thicknesses 534, 528. I think last week we were looking at thicknesses in the 500 region for really, really cold temperatures. This isn't super cold. 60 hours. And so by the time we get to Sunday evening, and this is 6 p.m. Sunday, we can do another temperature profile, another sounding, please, and we'll see close to Madison. We're now, here's the zero isotherm right here, and we're going to be basically right at freezing the whole depth of it. So anything falling at this point, as suggested by the algorithm, is likely to be snow, and that makes a lot of sense. How much is expected to fall? With this, we assume a 10-to-1 ratio. Scroll down. We can look at the 24-hour accumulated precip, since it's probably going to turn to snow sometime after we get to sometime in the afternoon on Sunday. And we'll get probably about an inch or so. But to our northwest, well to our northwest, in parts of northeastern Iowa, and we look at 6 to maybe 10 inches of snow or so. And the forecasts have been pretty consistent over the last several runs of keeping the heaviest snow well to our northwest, maybe Eau Claire to La Crosse and areas just south of Minneapolis. As an example, if we go back to the 0Z forecast, valid at the same time for the total accumulated precipitation, was pretty much the same. It's actually lighter snow here, with the heaviest still going north. And with the 6Z run, still going northwest, but back even further to the west. We'll watch that in the forecast to see how that changes. We want to go back to the 12Z run and look at the NAM.
I think we're looking at the snow, but the actual liquid, I think, is quite a bit over us.
Right. Yeah, this is just snow. We'll look at the total accumulated. Here's the NAM. Also, it has actually a better resolved band that's well to our north than this. So we go back and we look at the liquid precipitation, 24-hour QPF.
That's not bad.
Actually, look at total because it's going to be longer than 24 hours for this. So we're looking at close to an inch of liquid precipitation over us from the NAM. And if we go to the GFS, the NAM is the North American model. This is GFS, the global forecast system. Actually has a heavier amount, well, more or less.
What about the new GFS?
And the FD3, that's going to be going online in late January, the new global model for the US. It's a different depiction. So
Ah.
almost sort of these heavy precipitation.
And the ECMWF is very close to the GFS.
Has been recently. We don't have the output for this.
Still looks very similar.
Well, I was looking at it earlier, but it's very close to the GFS. So this one's more similar.
Right, so this is the FD3, and this is just freezing, cumulative freezing rate. So for the weekend, looks like just cloudy, the rain beginning late Saturday to early Sunday, and continuing, becoming more mixing with it, maybe changing over to snow by the time we get to Sunday evening. If we go back, this is, if we go back to the cumulative precip, well, not FD3, but GFS. Surface. One last thing, we'll go 6 hours further ahead just to watch as this very elongated cyclone center. That one's filled. The main cyclone center is now in Quebec, and maybe another one developing in maritime Canada by this time period. The question that Greg asked is an interesting one. Why is this sort of slowing down and getting stretched out? And I really think if we were to look at the evolution of the 850 millibar thermal wave, we saw the beginning of that trowel structure forming, but the wave, this upper wave itself begins to almost cut off, and the surface wave sort of ripples ahead, well out ahead of it. So we go to 500 millibars. We could either use your map speed or the ones that are provided on this thing. Dynamics 500. And go back to 6 hours. Let me just quickly step through these. Here's our wave forecast coming into the southern plains this evening, and the speed just advances. It will go 12 hours. Fairly impressive curvature maximum. By the time you get to cut off at least at the height field over Oklahoma. I remember we have that thermal wave that's out ahead of it. We'll see that in a little bit. Another 12 hours ahead. This just cuts off, and if you're cut off, you're not going to be able to propagate as rapidly. I think that may be part of it. We've also built this massive ridge blocking the northward progress of it. So it's not going to go to La Crosse, it's just going to sort of spin out. It's going to take a while to get there. And as the wavelength of this is increased, to the extent as anything will lost be wave-like, it's going to probably slow its propagation as well, but it's a nonlinear vortex.
So what's different from other years when this usually doesn't happen? I think what's different is we don't have a strong Arctic system plunging in behind it.
That may be it, and if we're weekly El Nino-ish, we saw fire convection in the Pacific earlier, and Pete's loops.
Yeah.
The southern, what do you call it? The subtropical jets can be more active, and maybe you have a lot more going on the low latitudes, not much going on in higher latitudes. If we could go to 850 for one last thing, temperature. I think we'll see the 850 wave doesn't get cut off. It just continues to propagate to the northeast. And that'll be the last thing we'll show. So the thermal ridge at 850, we go back to 6 hours. And this is downslope, that's why it's warm here, and then we have the advection of warm air from the Gulf. This is not the best depiction of it, but you watch this thermal ridge that's right in here to the southeast of the wave. Maximum is out here now, over Indiana and Illinois, and you're still getting stronger warm advection out, well out to the east of this cyclone. Whereas the upper trough is stuck back here, this thermal ridge, to the extent you can
Nothing's coming in behind it.
Yeah, nothing's coming in behind it here, but this thermal ridge itself is going to be
The cold air, there's no cold air dropping into the high plains of North Dakota. There's some, but it's not very much.
That's not super cold. Some of this might be weakly upslope. But the point I wanted to make was the upper trough is stuck back here. The thermal ridge, which is going to associate with its own cyclonic circulation, the PD inversion, it's going to be out here, and the separation of those two is going to help elongate the whole structure of the system. I think that's at least part of it. But why you get that might have something to do with why we've seen it at least 2 times in a row.
I think your comment about El Nino is very interesting in that we are moving into the El Nino, and this might be an El Nino pattern.
Right.
Because this is the type of weather you get with El Nino, right?
Right.
Halfway cold. Precipitation, nothing much.
Michael, one last thing I want to show is we go to the CFS. This has been somewhat persistent. We go to anomalous temperature anomalies, 2-meter temperature anomalies at surface. Go back to, this is now 60 hours, that's pretty much now. If we go ahead to next week, kind of cold, that's a period of about a week or so of really cold temperatures. Go ahead another week after that, or just go to 432, let's say, just to, we go warm, again, 12 degrees above normal is going to put us in the upper 30s or so, low 40s. Go out further ahead. This is mid-December. If this dynamical model has any accuracy, it's going to be a warm period that's going to be occurring through much of the this
It
upcoming.
totally looks El Nino.
Yeah, so we get cold this week, the next week, and then it looks like, fingers crossed, if you like warmer weather, we're probably moderating. And what does it mean to be warm at the end of December? We're looking at temperatures at 0Z of 27, so 6 p.m. 27. We've already experienced that this winter. So this isn't too bad. I'm not saying I believe it, but that's the trend. Is if we look at these model forecasts continually at the far end, they actually warm up. So, all right. Well, thank you for your attention. We'll kind of weather watch. Last weather watch of the season will be next week, Friday. And then we're in exam period. So thank you for coming. Thank you for the map.
This totally looks El Nino. But in 1998, when we had that El Nino,